Okay, so today we'll move on and towards topic number 7C, which is known as the particle zoo. It's a complete madness around here when you talk about particles. There are different types of particles and not just particles, then those particles have their anti-particles as well. If a matter has its antimatter, particles can have their anti-particles as well. You should be knowing and understanding the different particle interactions for that as well. Talking about creation, implication from the most creation stories that from nothing, the material of the earth was also brought into being by an unexplained entity. Nobody knows how the earth formed as well. A bunch of rocks, a bunch of clouds of gases together. Even if we talk about the most important theory that was the creation of matter, creation of energy, creation of universe, to chalo, is the Big Bang theory that has already been approved and all through the shifting wavelengths, the increasing distances, recessing speed, increasing wavelengths day by day, proving that universe is expanding day by day as well, and it had a whole explosion known as the Big Bang theory. However, Einstein's most important theory suggests exactly this, that matter can appear where previously there was nothing but energy. Matter and energy then regularly interchanged in the universe according to E is equal to mc square. In this equation, multiplying the mass of an object by the square of speed gives the equivalent amount of energy. And given a suitable quantity of energy, such as that in gamma ray photon, particles can spontaneously appear and the energy disappears from the existence. This is so common in the universe that should not surprise us. The reason is does that these events only happen on a subatomic scale, so we cannot detect them without complex machines. Got it?
Okay.
Many
Yeah, मैं
particles can
sure
be
thing.
spontaneously appear, right? और उसको ये है कि ये events are random as well. जैसे एक decay होता है, when an atom starts decaying, that is completely random as well, but we are focusing on E is equal to mc square. और ये जो E है, this is energy of any particle. मतलब photon की बात हुई तो this energy is also equal to is equal to mc square. This energy is also is equal to hf, and the same energy is also equal to hc over lambda. A gamma ray photon converts into an electron and positron, an anti-electron that has the identical mass to the electron. Calculate the frequency of gamma photon. We don't have the mass. We only have speed of light, but we do know that they said that it's an identical mass to an electron. What is electron's mass? Multiply that by the square of speed of light and you will get what? Energy. Once you have energy, you can use this equation, rearrange it to find the frequency, which is energy divided by the Planck's constant. Clear?
जी.
This reaction is known as the electron-positron pair production. In momentum terms, it is just like an explosion. Initially, only the photon existed, so there was some linear momentum along this initial direction. Their components of momentum must sum to the sum total as the photon head. Perpendicularly to the initial momentum, the electron and positron that were produced must have equal and opposite components of momentum, so that in this direction it will still be total zero afterwards. We are going to talk about pair production. यहाँ पे क्या हो रहा है? This is known as when an electron and a positron combine together like an explosion, or in my initial directions being, it's kind of like the 2D momentum, how they are going to collide, how their directions are going to change, and all of that. And in any reaction, the total combination of matter energy must be conserved. If we add the energy equivalent of all matter particles with the energies before and after the reaction, the numbers must still be equal once this collision has taken place. अब इधर भी energy produce होती है, and again when these electron and positron are collided, they must have equal number of momentums as well. But the thing is that they should be traveling in opposite direction. Only then they are going to collide as well. Similarly, like the pair production, we have another very important concept known as annihilation. Matter can appear spontaneously through a conversion from energy in the same way energy can appear through a disappearance of mass. This is the source of energy in nuclear fission and fusion as well. मतलब कि we know कि obviously when these spontaneous reactions occur through the conversion of energy, same way energy can also appear through disappearance of mass. And this is the source of energy in nuclear fission as well, nuclear fusion as well. In both reactions, the sum of the masses of all matter involved before the reaction is greater than the sum of mass afterwards. This mass difference is converted into energy, and in a nuclear power station we extract this energy as heat, और फिर हम उस heat से steam बनाते हैं ना, वो steam जो है that is going to run the turbines, और वो turbines फिर generator को चलाती हैं that produces
ये एक
electricity.
एफिशिएंट मेथड है एनर्जी प्रोडक्शन प्रोडक्शन के लिए।
किस चीज़ के लिए?
ये एक एफिशिएंट एनर्जी प्रोडक्शन मेथड है।
This is an efficient energy production method,
हाँ।
हाँ कह सकते हैं. It is just expensive. It is energy efficient
अच्छा।
as well, और it is renewable as well. It is yeah, बिल्कुल है.
ओके।
If a particle and its antiparticle meet, for example, electron meeting its antiparticle positron. If a particle and its antiparticle meet, antimatter versions of regular particles, they will disappear to be replaced by the equivalent energy. We call this interaction as annihilation. This reaction was supposedly the main power source to drive the Starship Enterprise in the science fiction series Star Trek as well. जैसे एक मूवी बहुत मशहूर है Star Trek as well, एक सीरीज है बल्कि, and इसमें एक starship होता है Enterprise as well, that is also running on the same energy which is annihilation. ये annihilation reactors could not be used as a power source on the earth because antimatter exists very rarely. इसी तरह बहुत सी ऐसी energies हैं that are only present in space which cannot be used on earth. Also, if we could find a supply of antimatter, it would annihilate on contact with the matter, and this would most likely be before it reached the reaction chamber we had set up to use energy for conversion into electricity. This is that famous Enterprise starship from that series as well.
एंटीमैटर कोई फिजिकल चीज होती है?
No, जैसे मैटर है बाकी उसी तरह we have antimatter. Yes, it's a physical चीज बिल्कुल. It's also like the matter, but it's antimatter. It's a different type. It's a whole particle zoo, as we explained. It's a whole madness. Every particle has its antiparticles as well. Every quarks have its down quarks. Every you can say neutrino has its anti-neutrino as well. Baryons, hadrons, leptons, अभी हमने आगे बहुत सारे और भी कवर करने हैं. Pions हैं, bions हैं. A lot of different particles that you will be seeing. What is electron volt? What is electron volt?
एक मेजरमेंट होता है।
Of what?
हम लेते हैं, ठीक है, इलेक्ट्रॉन वोल्ट मल्टीप्लाई करते हैं
What is
हम
it?
पर सीखते।
किस चीज का यूनिट है इलेक्ट्रॉन वोल्ट? यूनिट वन से पढ़ते आ रहे हैं हम.
एनर्जी क्या होता है?
एनर्जी, वेरी स्मॉल अमाउंट्स ऑफ एनर्जी.
हाँ,
Remember
ये
that one electron is the amount of energy gained by an electron when it is accelerated through a potential difference of 1 volt. How do we convert from joules to electron volts and electron volts to joules?
मल्टीप्लाई बस करते हैं, मल्टीप्लाई करते हैं अगर आपने वापस कन्वर्ट करना है।
किस चीज
हम
से?
पॉइंट सिक्स हम पॉइंट सिक्स टेन पर माइनस 19।
Good. So it's a very
अगर
small
आपने
amount of
वापस जाना है तो
energy.
डिवाइड।
Hmm. So it is very common for particles to have billions of electron volts as well. So we are going to use mega electron volts, giga electron volts, units of energies in these particle interactions. The atomic mass unit U is not an SI unit, but it is often used in particle interactions as well, as it is very usually easier to understand that 1 U means what? 1.66 into 10 to power minus 27. तो अगर आपसे कोई mass of proton या mass of neutron पूछे, it is also what? 1 U, which means 1.66 into 10 to power minus 27. और अगर आप इसको divide कर दोगे कोई 1836 से, that will give you the mass of electron, right? Which was 9.11 into 10 to power minus 31. Clear?
जी।
So all of these energies will be either be in mega electron volts or giga electron volts. First, let me show you what is basically happening in this annihilation, antiparticles, and all that stuff. Can you see the screen?
जी।
Hmm. इसके हम subtitles भी on कर लेते. We can turn on the captions and then watch, listen very carefully. This will help you explain your question, which was about antimatter, antiparticles, and the annihilation plus the pair production reaction as well, with the electron and positron were actually colliding and all.
Hello everyone, welcome back to Z Physics. Today we're going to be talking about antiparticles and annihilation. Now first off, what are antiparticles? Every regular particle has its antiparticle, and antiparticles have exactly the same mass but opposite charge. For instance, we have the electron, which is our regular particle.
You can hear the video, right?
जी जी
I'll randomly pause and ask you questions as well.
ठीक है
And that has a mass of 9.11 times 10 to the power minus 31 kg and a charge of negative 1.6 times 10 to the power of minus 19. A positron is the antiparticle for the electron. It has a mass of 9.11 times 10 to the power minus 31 kg, which is exactly the same as the mass or as the rest mass of an electron, and it has a opposite charge which is plus 1.6 times 10 to the power of minus 19 coulombs. So the way we write down an antiparticle is normally with a little dash on top. For instance, if we have the proton, which is our regular particle, the antiproton is going to be written like so, just like a proton with a little dash on top. So this particle here, the proton, obviously has a charge of plus 1.6 times 10 to the power minus 19, whereas the antiproton will be a negative particle with a charge of minus 1.6 times 10 to the power minus 19 with exactly the same mass. And we could extend this to virtually any particle. For instance, let's say this here is the neutrino, and the antineutrino will be written like this. Here's where it gets really interesting. When matter meets antimatter, annihilation occurs. This means that the entire mass of the two particles that have met, one particle and one antiparticle, is converted directly into energy, meaning photons. One of the most common questions is, why does that happen? Well, if we were to describe the two particles, the particle and its antiparticles, they're actually going to have opposite what are known as quantum numbers. And if you do physics at university, you're going to be doing quite a lot about quantum numbers. The overall quantum number after the annihilation event, when a particle interacts with an antiparticle, is 0. And this means that normally photons emerge. Let's have a look at an example of this. Here's an example of a Feynman diagram showing an annihilation event. We have an electron and a positron interacting, and the resulting annihilation produces two photons. Notice that the two photons are going to be traveling in a direction such as to conserve the original momentum. For instance, one here is going to the left and one here is going to the right, and overall there the total momentum will be 0, assuming that the total momentum was 0 before the collision. So what will the minimum energy of each of those photons be? And this is an incredibly typical question from the A-level physics specification. In order to calculate the minimum energy, we're going to use the most famous equation in the history of physics, E is equal to mc squared. In fact, because now we're talking about the change of energy and the change of mass, I'm just going to add a couple of little deltas right here. The total change in mass will actually be twice the electron mass, because the electron and the positron have exactly the same mass, so our total change in energy will be equal to twice the electron or the positron mass times c squared. And this over here is the energy, the total change of energy. Because we're trying to find the minimum energy of one photon, and they're going to be exactly the same, we can divide this by 2 in order to figure out the minimum energy of just one photon. So essentially the 2 is going to cancel out. So delta E will be just equal to the mass of an electron times c squared. We're ready to plug in some numbers. The mass of an electron is 9.11. times 10 to the power minus 31 kg, and the speed of light is 3.0 times 10 to the power of 8 squared. And if we multiply everything out with a scientific calculator, we're going to get approximately 8.2 times 10 to the power of minus 14 joules. And this will be the minimum energy of each photon. We could also convert that to electron volts, which is quite a typical number. And the way we are going to do that, let's actually convert it to mega electron volts, will be by dividing by the electron charge. So let's convert it to mega electron volts. So it's going to be 10.6 times 1.6 times 10 to the power of minus 19, like so. And this is going to give us approximately 0.51 mega electron volts. We could take this a step further and calculate the wavelength of the photon that we are expecting to come out of this annihilation event, or the frequency. Let's do the wavelength. Remember, the energy of a photon is given by the following equation: E is equal to hc over lambda. Rearranging for the wavelength lambda, we're going to get that this will be equal to hc divided by the energy, which is equal to 6.63 times 10 to the power of minus 34 times the speed of light, which is 3.0 times 10 to the 8. Let's just divide that by the energy, which is equal to 8.2 times 10 to the power of minus 14. And if we were to input this into a scientific calculator, we are going to get approximately 2.43 times 10 to the power of minus 12 meters. Okay, folks, now just to recap, there are two types of matter, matter and antimatter. They have exactly the same mass, but they have an opposite charge. When matter and antimatter interact, they annihilate, producing photons. We could use delta E is equal to delta mc squared to calculate the energy of the photons. There's two of them to conserve momentum. If we wanted to, we could use E is equal to h0 lambda to calculate the maximum wavelength of these photons, which in this case for the electron-positron collision is about 2.43 times 10 to the power minus 12. If we wanted to, we could also use E is equal to hf to calculate the minimum frequency as well. Hopefully this makes sense. Thank you very much for watching, and I'll see you in the next video.
Any problems?
नहीं
Good.
लेकिन ये इक्वल एमसी स्क्वायर ये रेस्ट एनर्जी भी चाहते उसको या पोटेंशियल एनर्जी
ये एक एनर्जी है दैट कैन बी ऑब्वियसली कोई भी हो सकती है अगर वो पार्टिकल मूव कर रहा है तो इट इज काइनेटिक इट्स जस्ट एन एनर्जी ऑफ दैट पार्टिकल एनर्जी ऑफ अ फोटोन रे वेव एनीथिंग पार्टिकल
वो कोई भी हो सकता है
कोई भी हो सकती है जिस मर्जी फॉर्म में कन्वर्ट हो वो
अच्छा और एक दूसरी चीज ये क्योंकि अगर आपके पास वो एंटी एंटी न्यूट्रॉन भी होता है
एंटी न्यूट्रॉन has a different name. We'll study that in hadrons and bosons as well. Yes, it has different name.
अच्छा लेकिन वो कोलिजन करते हैं ज्यादा प्रोटॉन के साथ या
This is
एंटी
just an
प्रोटॉन
example
न्यूट्रॉन के
जो अभी
साथ
आपने देखी pair production या annihilation. This was about electron positron or the protons one as well. बाकी you don't have to
नहीं
study.
लेकिन अगर मैस एक जैसा है क्योंकि प्रोटॉन न्यूट्रॉन का मैस एक जैसी है
It is
लेकिन वो
possible,
ऑपोजिट के
yes,
साथ हो
but
सकते हैं अच्छा ठीक है
experiment tested नहीं है. I never heard of it.
अच्छा अच्छा ठीक है
After a century in which scientists rapidly discovered now many subatomic particles, you have already studied me with me the discovery of proton, discovery of neutron, discovery of electrons. Now they have established a theory for how these all the theories come together to construct the things now we see around us, because all the things are made up of atoms, and all the things we call and we see around us is matter. Matter made up of atoms, atoms made up of the subatomic particles that we have discovered. This theory is known as the Standard Model, and the idea of the atom as indivisible was swept aside by Rutherford and Thomson as the idea of the proton and neutron being fundamentally has been overturned. We have probed inside these two nucleons and discovered that inside those two nucleons, मतलब कि protons and neutrons also contain some quarks. Got it? These are both known as nucleons and इनके अंदर एक quarks हैं. What are quarks? Smaller particles. Electron is still considered fundamental. What does the term fundamental mean? Cannot be broken further, you
नेसेसरी,
can say. उससे फर्दर आप नहीं ब्रेक कर सकते. इलेक्ट्रॉन फंडामेंटल है, ये
बिल्कुल
बेसिक है.
बेसिक।
इलेक्ट्रॉन मजीद cannot be broken down. But protons and neutrons have been seen that they are broken down into quarks. They have these smaller particles known as quarks. And there are two types of quarks. All of them you can see over here. The most common ones that are found in the protons and neutrons are the up quarks and the down quarks. Similar types of particle, all of them have a neutrino associated with as well, forming a group of total six fundamental particles known as leptons. Scientists like to see the
वो
universe.
ग्लूऑन्स भी नहीं होते कोई ऐसे?
वो भी आगे आएंगे, सही कह रहे
अच्छा।
हो. Scientists like to see the universe as balanced or symmetrical, and we have now found that quarks are also a group of six, although only the lightest two are found in protons and neutrons, जिनको हम up quarks और down quarks कहते हैं. बाकी जो heavier quarks हैं, they are found in rarer particles, and the two groups are different because quarks can undergo interactions via the strong nuclear force. But leptons do not experience the strong force. It is the strong nuclear force that binds nucleons together in the nucleus, and in the each group of six there are three pairs with a similar order of magnitude for mass, and these are known as the three generations of matter. Clear?
जी,
Don't have to memorize
ये
all of
सारे
the
याद
things.
करना है?
I'll tell you which ones you have to memorize once we're done with the whole chapter. These, yes, you have to memorize all of them. When we talk about the sixth family of quarks, you have to memorize all of these. Clear?
ओके।
Only the first three quarks, जो कि up, down, and strange, were known to form the middle part of the 20th century, and the charm quark was discovered in 1974. Symmetry of the standard model indicated to scientists that there were other particles they had never been observed, including the bottom and the top quark, and hence experiments were further carried out in the same Fermi lab in the same accelerator to discover those as well. Current particle theory believes that all matters in the universe is constructed from the combinations of some of these 12 particles and not others. और वो 12 particles आपने टेबल ए और बी के अंदर देख लिए हैं. These antiparticles have the same mass. हम स्टडी नहीं करते क्योंकि हमने ये वो assume कर लिया that they all have the same mass. इससे छोटा अब क्या ही हम measure करेंगे mass, right? And the other properties are opposite to those of the normal matter particles. हाँ, ये चीज़ confirm है कि antimatter सबका mass एक जितना है, but all of the properties are exactly opposite to the matter. एंटी मैटर है तो ऑपोजिट टू मैटर, एंटी पार्टिकल है तो इसकी प्रॉपर्टीज ऑपोजिट टू इट्स पार्टिकल एज वेल विद अ
लेकिन ये
बार क्लोज.
एनिमेशन में ये कैंसिल होता है ये चार्जेस पूरा?
फॉर एग्जांपल, नहीं नहीं, अगर एक न्यूट्रिनो है, दिस इज अ पार्टिकल,
हम्म।
इसका एंटी न्यूट्रिनो होगा, हम उसको एक बार से शो करेंगे, जो बार लिखा विद अ बार अबव द सिंबल एवरी वन विल हैव. अगर मैं कहूँ कि एक अप क्वाक है, दैट विल बी +2/3, मैं को नहीं, इसकी एंटी क्वाक क्या होगा, तो -2/3 उसकी हम वैल्यू कर देंगे. लाइक दिस इन द टेबल यू कैन सी दिस इज अप क्वाक. इसी का अगर एंटी अप होगा तो वो बिल्कुल सेम मैस होगा, सेम चार्ज होगा, सब कुछ सेम होगा. वी आर ओनली सेइंग दैट बिकॉज अब इनसे भी छोटे मैस, अब इनके भी हम मैसेज क्यों याद करें, इतना कौन अब घुसे, हमने खुद ही अज्यूम कर लिया दे ऑल हैव द सेम mass. But all of these antimatters and antiparticles have properties opposite to their original particle and original matter. Clear?
प्रॉपर्टीज मतलब?
Properties, for example, अभी डाउन क्वार्क जो होता है, डाउन क्वार्क इज -1/3.
हम्म।
इसका एंटी डाउन क्या हो
ये
जाएगा,
तो
इसको
चार्ज होता है।
+1/3 कर दें. दिस इज अ पार्ट ऑफ
अच्छा,
दोज
लेकिन
प्रॉपर्टीज
चार्ज के
ओवर
अलावा
हियर.
कोई और है
नहीं नहीं,
प्रॉपर्टीज?
नो 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 स्पेसिफिक प्रॉपर्टीज, नथिंग. वो आपके इसमें डाले नहीं है
अच्छा।
कि प्रोटॉन में कितने अप हैं, डाउन डाउन हैं, ऑल ऑफ दोज यू डोंट नीड टू नो दीज एज वेल. और
अच्छा।
वैसे यू शुड नो दैट प्रोटॉन्स जो होते हैं, अप क्वार्क्स जो है दैट इज +2/3, और डाउन क्वार्क्स जो होते हैं वो -1/3 है. गॉट इट? अप
ये
क्वार्क इज व्हाट?
जी।
आई टेल यू. प्रोटॉन्स जो होते हैं वो होते हैं UUD. ओके, उसमें तीन क्वार्क्स कौन से, अप, अप और डाउन. अप क्या होता है, +2/3. दूसरा अप भी क्या है, +2/3. और डाउन वाला क्या होता है, -1/3. और जो न्यूट्रॉन्स होते हैं ना, दे आर अप डाउन डाउन। न्यूट्रॉन्स के अंदर कौन से होते हैं? अप डाउन एंड डाउन, मतलब कि +2/3,
हमेशा तीन होते
-1/3,
हैं।
-1/3, एग्जैक्टली यस। और अगर आप इनको
अच्छा।
ऐड भी करोगे ना, इनको अगर
और
आप ऐड
इलेक्ट्रॉन।
करोगे अप अप डाउन को, तो आपके पास 1 आएगा आंसर। क्लियर? +1
और
मतलब
इलेक्ट्रॉन।
प्रोटॉन का +1 हो गया, ठीक है। इलेक्ट्रॉन का नहीं, इलेक्ट्रॉन इज फंडामेंटल। Electron cannot
अच्छा।
doesn't contain anything. Electron can't be further broken down. Protons और neutrons fundamental नहीं है. They can be. They have quarks inside them. Neutrons क्या है? Up down down, मतलब कि अप क्या होता है +2/3, डाउन क्या होता है -1/3, एक और डाउन क्या होगा -1/3। सम ले लो, you'll get
तो
0.
बच गया जीरो।
So that tells you
तीसरे
that
चार्ज जीरो +1।
exactly neutrons are neutral.
अच्छा ठीक है।
प्रोटॉन्स का देखोगे UUD होते हैं, +2/3, +2/3,
लेकिन
-1/3 के
इलेक्ट्रॉन के चार्ज होते हैं -1, तो मतलब उसका,
-1। बट इट्स
मतलब
द
तो उसका।
मोस्ट फंडामेंटल वन। लेकिन अगर आप इलेक्ट्रॉन का बात करो तो इलेक्ट्रॉन, एंटी इलेक्ट्रॉन का अगर आप नाम लो, एंटी इलेक्ट्रॉन इज नोन एज पोजिट्रॉन, दैट यू सॉ इन द वीडियो एज
नहीं,
वेल।
लेकिन इलेक्ट्रॉन मानने का डी फिर। नहीं।
नहीं नहीं नहीं,
माइनस
इलेक्ट्रॉन
वन
है
बाई
ही
थ्री
नहीं
माइनस वन बाई
क्वार्क्स।
थ्री माइनस
इलेक्ट्रॉन्स में अगेन मैं तीसरी बार रिपीट करूँ, इलेक्ट्रॉन्स आर फंडामेंटल। इलेक्ट्रॉन्स डोंट कंटेन एनीथिंग।
लेकिन।
इलेक्ट्रॉन खुद ही सबसे छोटे हैं। उसका चार्ज कैसे है वो आपने ऊपर डिस्कवरी में पढ़ लिया था उसके। इलेक्ट्रॉन्स हैज नथिंग टू डू
अच्छा
विद
तो कोई।
क्वार्क्स।
अच्छा ठीक है।
यस यस, इलेक्ट्रॉन्स आर
तो
फंडामेंटल।
कॉन्सेप्ट अप्लाई नहीं होता इधर फिर, ठीक है।
नहीं, इलेक्ट्रॉन्स आर फंडामेंटल।
ओके।
इससे छोटी चीज
ठीक है।
नहीं है कोई। प्रोटॉन्स एंड न्यूट्रॉन्स से छोटी चीज ही क्वार्क्स थी जो हमने कर ली। प्रोटॉन्स एंड न्यूट्रॉन्स आर
अच्छा।
मेड अप ऑफ क्वार्क्स। इलेक्ट्रॉन्स आर नॉट मेड अप ऑफ एनीथिंग। इलेक्ट्रॉन्स ही सबसे छोटे हैं।
अच्छा
क्लियर?
ठीक है।
So we have talked about quarks, the fundamental particles. Leptons were just six fundamental particles. Antiparticles have all the same mass, but they all have the properties which are opposite to those of the normal matters. Clear?